Hello and welcome back to my Retro Games Memories video series. Today we're going to be looking at some Amiga stuff. Don't worry, we'll be going back to the Commodore 64 stuff soon enough, but I was looking through some old Amiga Format magazine scans and I remembered how a series of magazines had on their cover disc the Menace source code and how you can program games and introduce the Devpac and Argasm assemblers. So I thought, crazy old me, let's see if we can actually get this old source code assembling with the old assembler that was provided by the magazine and see if we can do some other interesting stuff with it and reminisce a little bit about the old Amiga. So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel or sending me a super thanks. They are all always very much appreciated. In the background, I've been throwing up some of the old scans from the Amiga Format magazines that are relevant to this video. We have these rather lovely articles at the time. They were fantastic for an aspiring programmer like myself. And what I want to do is that I want to have period correct versions of Kickstart and Workbench and also the software. So we're going to be targeting around 1990, and the first Amiga format cover disk that we want to have a look at is cover disk 7, and then I think it goes to cover disk 8 and 9. So we need some software. Now, I don't have a working Amiga at home, unfortunately, and to be honest, it's going to be a little bit difficult to find one. It's short notice, so we'll be using WinUAE. WinUAE is a very mature, very accurate emulator. It also has a rather nice little debugger as well, and it runs really well on Windows PCs and other platforms too. So all you need to do is that I just downloaded the zip archive version. I didn't run the installer. I just like a nice portable file that I can just run. Now when we run WinUAE, we get some WinUAE properties come up so we can configure the type of machine that we want. Now, because we're targeting late 80s, early 90s, I want to have an Amiga 500 with a little bit of expansion RAM in it, using 1.3 Kickstart ROM, I think, because it's period correct when I was doing some Amiga stuff. I didn't do that much Amiga stuff. I did, 3D graphics and some demos and some 2D games and stuff like that. But I very quickly moved on to a different computer called the Acorn Archimedes, which was very popular in the UK at the time and actually produced several games for that. But yeah, Workbench 1.3, I definitely remember using 1.3 and later on using Workbench 2, of course, but that was later. I want to stick with Workbench 1.3. So we will need the Kickstart ROMs. Now I'm going to be committing all of these links and everything to an information file like I normally do in my debug details folder and committing that to GitHub. So you can also see all of the stuff that I'm downloading, but basically it involves quite a lot of Googling for all of the things that you need. But I will, as I say, put the collected links into a text file so that you can download the same things that I'm downloading and you don't have to worry about finding the right version. If we go into archive.org, the website, and what we can do actually is that we can click on the Show All button, and then we can have a look at all of the lovely Workbench revisions that have been archived. We need to download the relevant versions. For Workbench 1.3, if I remember rightly, there were at least 2 disks that we need. We need the Workbench and the extras disk. And we're going to be having an emulated Amiga 500, but we're going to be adding a hard drive. I don't really want to disk swap with floppy drives a lot. I really want to use a hard drive. I think that went in the trapdoor slot in the bottom of the computer. Anyway, so we can configure WinUAE to use the fastest possible CPU, and also we can configure the expansion RAM here. We can configure the speed of the floppy drives as well. We've got 2 floppy drives. We'll use the turbo option. That means the floppy drive emulation is really very, very quick. Now what we want to do is that we want to find those workbench files. So we'll do that and put them in df0 and df1. Actually, I'm looking for the GB version of Workbench, the British version, not the version from wherever it was, Netherlands and Denmark, I think, or something like that. So we'll download the GB versions and we'll use those. I noticed that I was trying to open the wrong ADF files earlier on, so let's use those. Now, when using WinUAE, it's important to use the three dots, the ellipses button to actually browse for the file that you want. Just pasting it into the text box there doesn't seem to work that reliably. So anyway, we've got a DH0 hard drive and we've set it up to be volume name system, and we can set it up with a path to a directory. And with this path to a directory, it allows us to actually browse the files from the host, from Windows, as the Amiga is running. Now this is very useful because then if you want to view the files and more easily back them up later on, you can. I think it's a better option than having a disk hard drive image, for example. The disk hard drive image is just one great big binary blob of a file, and it's slightly more difficult to have a look at the files inside and to manage the files. Which reminds me, we should be installing directory opus as well to make file and directory handling and disk handling a lot easier. But first we need to install Workbench. Now Workbench 1.3, if I remember rightly, there wasn't an install option per se. All I used to have to do, if I remember correctly, was just to copy over the files from the two Workbench disks onto the hard drive, and then that was it pretty much installed. You can do all sorts of configuration with the start file and everything like that, but yes, this is what we get when we run from the floppy disks. So we have the two floppy disks on the right, the Workbench 1.3 and the Extras 1.3 floppy disk icons. We also have the system disk, which is an empty hard drive, and we have a RAM disk by default, which is an empty RAM disk. They're practically empty. They are initialized with some files and some directory structure, or at least some directory structure if I remember. But that's not really important right now. So let's open up the Workbench 1.3 floppy. We can see that we've got a shell icon, we've got some drive or folder icons. This is the standard Workbench 1.3 color scheme and graphical layout. This reminds me. Oh gosh, all of these basic examples that you can run. So there are some quite cool basic examples which, if you came from a personal computer like the Commodore 64, then having a GUI interface, a nice GUI way of doing things, and having all of these separate draggable screens and everything with a mouse pointer and all sorts of things that just, directory structures and everything else, all of it in a nice graphical user interface. It was really quite fantastic having your computer with a little speech program that you can just run, and it opens up this window, and then you can just do stuff to make it say different things. Again, a very cool thing to actually do when exploring the Amiga in the early days. This was really interesting. So anyway, I digress. Let's get back on target. Let's open up a shell window, and then let's issue a couple of copy commands to basically copy all of the files from df0, colon, there we go, figuring out the key map, to dh0, which is the hard drive, and then just do a clone all. And now it's just going through and copying all of the files. And I'm going to skip ahead in the video here because this takes a while. The Amiga Workbench is a multitasking system. So you can actually have the Amiga shell running in the background, of course, and you can open up new windows in front of it, and you can do stuff. So you could say, for example, open up one of these utilities and then have that running as well as when the copy is going on in the background. Quite a mature multitasking operating system for such a computer back in the days was a little bit unusual. I mean, you had mainframes and stuff like that, but a personal computer, wow, it was relatively unusual. Let's put it like that. And now DF0 has finished copying. We'll press up and then edit to be DF1, and then we'll put all of those files on the hard drive as well. So we're just using the same copy command, but with DF1 colon, which is floppy drive 1 rather than floppy drive 0, DF0. Now we'll just wait for all of that to copy over. That's that done. Let's type end CLI. And now we can eject those two floppy disks. We can either click the OK button here, and then we can see that the floppy disks have disappeared. And of course, if you try and open it again, it will ask for the disk again, but we don't really care. What we actually want is that we just want to reset the machine now and let it boot from the hard drive, and that's what we'll do. Now we're just booting from the hard drive. This is the hard drive now. The floppy disks have been ejected, you see, so we have this nice little startup where it actually reads the real-time clock, and the WinUAE seems to be exposing real-time clock information, which is cool, right? So anyway, now we have that nice system icon, which is the disk icon for the hard drive. We've got a jumble of icons in the system window. Oh, here's the cleanup menu item, grayed out. We'll find out in a second. Let's just, there we go. That's better. Right, so now we can clean up and then we can unjumble the icons. There we go. All right, we're going to be adding some icons to this. So I think that's how you snapshot it. Well, we'll see how it goes. Anyway, so let's open up a shell. Let's do dir, and there we go. We've got all of the files that we need to run Workbench. Now, what we should do is that I think we should install something like directory opus. So this link here has a ton of ADF, which is the disk image file format. And we're looking for directory opus. We're looking for a period correct directory opus. I think that we'll use version 3.29, which is, 1991. 1.55, I think, was a little bit clunkier. So we'll use the later revision, I think. And PowerPacker as well is a tool that I used to use for packing executables and making them a lot smaller. We might need that later on, I think. So we'll just take a copy of that too, with the early 1990 version, I believe. So let's mount that new floppy disk image, rather, sorry. And it's not appearing. That's because I pasted it into the text box rather than using the ellipses method. You see, it doesn't work. So yes, let's use the ellipses method. Here we go. Press the ellipses button now as it's rebooting Workbench 1.3 in the background there. Now you'll notice actually that there's a boot block on this disk. And if you run it from the floppy disk, then we just get a directory opus floppy disk, and we get access to the icons, but it's not running the right version of Workbench. So if you try and do an install and you do OK, it's going to go right to file directory opus. Basically, it's trying to install itself on the floppy disk, which is not really what you want. What we want really is actually to have the floppy disk ejected first of all, and then reboot the emulator, and then have the hard drive being used to boot Workbench first. And then once we have Workbench booted with the hard drive install, it knows then that the boot drive for Workbench is the hard disk. So then when you insert the floppy disk image, there we go. Now when you run install opus, it should succeed now because it knows that it needs to install it to the hard drive, which is the boot device now, rather than the floppy disk, which was the previous boot device. There we go. Now it's doing all of the relevant file copies. We can see now that if I look in the Windows File Explorer in debugging details, the hard disk directory, and then there you can see that it actually installed the directory Opus binaries in the Amiga virtual hard drive directory path on Windows machine. So there we go. Now directory Opus should be safely installed on the Amiga hard drive, and we'll just reboot that. We're booting from the hard drive because there's no floppy disk image installed, and there we go. There's the icon for directory Opus. Of course, the icons have become all jumbled up again. I really need to clean that up, and I really need to snapshot it properly. Anyway, so if we run directory Opus now, you can see that we have a lovely Windows interface now for helping us to browse directory structures and the files therein, and also we can read the files, we can hex read them, we can copy them, and basically create directories a lot easier than if you're trying to use the shell. I know some people like using the shell. To be honest, I prefer using a nice GUI interface to file management. Hence, I would have been a good customer of directory Opus back in the day if I actually was buying any Amiga software, which I didn't really. So let's go to the Amiga Format cover disk 8, and let's see what we get. Let's reset the machine, and we got this nice little boot block intro, which then goes into loading kind of like a standard question in an Amiga DOS window. We don't want to run the demo of Xout. I want to load whichever version of Workbench is there. Let's have a look at the cover disk. And we have the Dave Jones folder, and inside the Dave Jones folder we've got the Menace scroll icon. Now this is a pre-assembled version, it's just an executable that's on the disk, and this is what the executable demo does. If we have a look at the document file, it tells us useful information about the files that can be contained or can be found inside. There's the Menace scroll.s file, which is the source code, for example, the doc file, and also some data files as well for the graphics. There's other stuff on this disk too, but we're not really interested in it. If I try and run directory Opus, it's complaining about a different version of the library that it's expecting to find, and that's because it booted load Workbench from the floppy rather than from the hard drive install. So let's go back to the hard drive install and boot from the hard drive. Nope, I got to eject the floppy. Oopsies. Right, there we go. Let's reset again. The great thing about, older computers like this is that it's really quick to just reset and cycle back around again and get back to where you were. Sometimes miss those days, Anyway, let's install that. Let's add that floppy disk image for Amiga Format cover disk 8 again. Let's clean up those icons. There's directory Opus. Let's use directory Opus on that Amiga Format disk, which is in DF0. And we can see all sorts of files in there. So if you have a look inside the Dave Jones folder, we can see that we've got scroll.s. If we open scroll.s, then it uses the directory Opus text file reader, and we can see that we've got source code. Quite a lot of source code. In fact, there's many pages of this. The formatting is a bit wrong because the tabbing is a bit wrong, but there we go. So we'll try and assemble this now using Devpac assembler. So we need to find Devpac assembler and actually get that installed first and get that working, and then we can use that to assemble this demo source code. We've got all of these ink bin directives at the bottom, which includes the binary for the foregrounds and everything else like that. So we've got the files that we need. We just need to be able to assemble them. So we need the assembler. Just before I forget, let's copy over the Dave Jones folder from the floppy disk to the hard drive, because we will need those files on the hard drive later on. So we select the Dave Jones folder on the left-hand view, which is DF0. And we'll copy over the info file as well for Dave Jones.info. Then we'll use the copy function to copy over a copy of those files onto the hard drive, which is DH0 in the right-hand pane view. Now we can see that we've got those files that we need on DH0 inside the Dave Jones folder. So we're very happy about that now. Now we've got the files that we need, we can quit directory opus. Back at the archive.org ADF archive, I think that we'll be using one of these versions of Devpac, one of the earlier versions, either 2.14 or 2.15. Now 2.14 was earlier, so we used that one, I think, 1989. We'll take the 2.14 Devpac ADF files and we'll add those to DF0 and DF1. So now we have both Devpac disk images attached. They should appear as two different icons. There we go. Now installing this, later versions of Devpac did have an installer option, I think, but earlier versions of Devpac just really didn't. We can see that it's got a whole bunch of utility folders and system folders and stuff like that. Basically, a kind of like a cut down Workbench distro, but we don't want the full distro. What we want is that we'll use directory opus to help us copy over the files that we want from DF0 and DF1 into the hard drive. We'll copy the files into DH0 Devpac 2 directory. So DH0 Devpac 2 directory on the right hand view. On the left hand view we'll have DF0. We created the Devpac 2 directory on the hard drive. It's empty right now, of course. We want the include directory. The include directory contains very important include files which contain definitions that the assembler can use when assembling source. So we'll need those. We will also need the assembler executables and also some library functions perhaps. What's in the libs folder? We'll just copy over those. Maybe we don't need them, but just copy them over anyway, I think. Yeah, let's copy those. What's in system? System, yeah, I don't think we need any of those. That's basically a bundle of some system files from Workbench. What do we have in the C directory? I think what we have in the C directory is that we have a whole bunch of expected DOS commands, as you would normally expect, right? But we also have the Devpac commands that we need. So we need the Devpac executables. There isn't blink on this disk. I think blink is on the other disk. But we do need genam and genim and monam. And I think that's it for those files. We'll just put those in the Devpac 2 folder on the hard drive. We don't need to highlight any of the other files from here because they're all part of the standard Workbench install that we've already got in the hard drive in the other directory. So we just click the copy button there for those 3 executable files. And in the parent folder, we need to copy over include. Maybe we should include one of the icon. Well, we'll copy over that, but I don't think it's going to be useful. Yeah, the README is going to be useful, I think. So now this is going to take a while because it's copying over all of the stuff in the include directory, which contains quite a deep hierarchy of folders, directories, and also the include files as well. There's a ton of them. So we'll just leave that there and then we'll come back to it. Before I forget, I think we'll copy over the examples folder. It's always useful to have example code, right? And let's look on df1 now, see what other useful stuff that we've got. Well, I think we'll copy over the fd files directory and the include CBM, include the Commodore includes, and the stripped includes, and also a library folder as well. We'll copy over blink doc. blink is a different linker that we can sometimes use, so we'll copy over those. And again, there's tons of files in this, so we'll come back to that later. After that's done, let's go into the C directory again and see what we've got. We've got blink, which is blink, and we'll just copy that over as well. There we are. Now that should be the Devpac 2.14 assembler all installed on the hard drive. Let's go back to the shell and then let's go to the Devpac 2 folder and then let's just run genam2. And there we go. There is the Devpac assembler window. Let's load a file. We've got a nice little file picker that we can use. We need to go to DH0 and then we need to find the Dave. We'll eject the floppy disk images now because we shouldn't need those. We'll just make sure that the install that we've got on the hard drive is good. So we'll just load the Dave Jones thing. We'll load scroll.s, which is the scroll demo source code. We should not need to change anything at all. We just should be able to choose assemble and then click the memory button and then click the assemble button and then pass 1, pass 2, and wow, look, 0 errors found. And it just run and then we should click run and there we are. We've just assembled it from source code and it's running the demo. So that was actually a lot easier than I remember it from last time, which is good, right? So that was really quite cool. So what we can do now is that we can go back to the assembler and we can try and assemble it to a file on the hard drive, I think. So we'll assemble it to a particular file. Hold on a second. I think we need to create a nice temporary folder. Where's a shell or directory opus? Okay, directory opus, we'll just use that. So we want to create like a temp directory. There we go, on the hard drive. Blink. Okay, and then we'll just quit directory opus and we'll go back to Devpac. There we go, and then bring the window to the front and then assemble and then disk and then hard drive dh0 : temp / and then we'll call it exe because it's an executable, right? And yeah, that's fine. So we've got executable or linkable. We want executable. Symbol case is dependent, blah, 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 blah. All of the other default options, fast assembly, assemble. Let's go. Let's see. I don't know why somebody would choose slow assembly. Maybe it uses less memory. Anyway, there we go. I've got the CPU speed cranked up and I've got the disk speed cranked up as well for the floppy disks and everything. That's why everything is a lot quicker. Okay, on an original A500 with the hard drive, this would have been quite a bit slower. Then let's run the temp exe file from the hard drive. There we go, it's still working, which is really nice to see. Let's have a look how large it is. No, dir doesn't show the size. List shows the size, and we can see there's 95 blocks used, 47,952 bytes, 47952. So let's use the PowerPacker disk image that we downloaded previously. Let's remember to attach it properly. There we are. It's hiding there in the background. We can run PowerPacker from here. We can also use directory opus to copy PowerPacker to the hard drive. Do we need anything else? PowerPacker, executable, document file, info files. We can either put it in tools, or we can either put it in, probably put it in utilities. Actually, I don't think tools is a very good place. Utilities is probably better. There we go, select the left-hand view and press copy, and then it puts it onto the hard drive, copies it to the hard drive rather. Now we can close that. We can open our utilities folder, clean it up. There we go, we've got PowerPacker. Large icons. Okay, I'm not too happy about the large icons. Oh, of course, PP more is no longer there because it's not on the hard drive. It was on the floppy. We don't really care about reading a document file with PP more anyway, I don't think. We're just really interested in the PowerPacker utility, and that's what we're running now. So let's get the directory. There we go. Let's go to temp exe. Yep, 47952. That's the uncompressed executable, of course. Then we run through and we let it crunch. We're just double checking that the CPU is running nice and quickly, and it should be. This crunching is a lot faster than it would be on an A500, I'm guessing. The compression tool that I use on a Commodore 64, actually, that's a relatively simple and easy decompression algorithm to write. Maybe I can write one for the Amiga, and then the Amiga would benefit greatly from having much better compression ratios. Anyway, we'll save that as exe-packed, and then we'll quit PowerPacker, and then we'll run exe-packed. Well, actually, we'll see that it's a lot smaller. A good saving, 27,000 instead of 47,902. And there we go, it still runs. And you'll notice that the mouse pointer was flashing different colors. That's what the depacking code does, is that it shows activity by flashing the mouse pointer colors. So I have a crazy idea. Let's make this a bootable, make this scrolling demo a bootable from disk demo scroller. So we're just having a look at the code. Well, first of all, we need to get rid of this alloc mem because we'll be running it from effectively from a boot block, or having a boot block load code. We'll be reusing the boot block, I think, from the red sector mega demo, because that one's very simple to use. But basically, what I'm planning is that we'll use position dependent code. We won't use position independent code. So at the moment, the code is position independent. It enters from Workbench nice and cleanly, or from a CLI nice and cleanly, and then loads the code into anywhere in memory, and then it goes and relocates the code effectively, or the code is relocatable, and then it allocates memory nicely in chip memory, and then is able to return back to Workbench. What we can do is that we can change the code to assume that it gets loaded at a particular address. We don't care about being nicely allocated, and basically take over the whole machine that way, and not even load Workbench, don't even load Kickstarter, well, don't even load, the CLI or Workbench or anything else like that. We'll just take over the whole machine straight from the boot block, like the red sector mega demo does. So to be able to do that, we need to know where the red sector demo loads its information from on disk, and where it loads the information to and where it starts running. So that we're going to use the WinUAE's debugger functionality for this. In this version of WinUAE, we can open the debugger by pressing Shift F12 while this main emulation window is highlighted. Pressing F12 just brings up the settings dialog, this WinUAE properties window. Let's just reboot, and then we'll try and catch the debugger before the boot logo comes up, because we want to actually trace into the boot logo. This is the textual interface to the debugger, and if we use the XX command, we can switch between console, the textual interface, and the GUI debugger. Sometimes the GUI debugger is easier to use, and sometimes the console is easier to use. It's mostly a personal preference. We can see at the beginning here, we can see the memory dump window. We can also see the disassembly window there. We can see some register states and machine states and all sorts of stuff. We can use the question mark command again to show the help for the debugger, which is always useful. We want to step forward until the PC, the program counter, is in RAM. At the moment it's in ROM. It's doing its kickstart thing where it's interrogating the hardware and looking at drives and stuff like that. Now we're in the RAM, and we're in the RAM at address 1564, which is what the PC is. I'm looking through the help here to look for a specific command. I'm looking for show PC history, which is either capital H or double capital H for full history, which includes the register dump for each instruction. We can see here that the excuse me, that the ROM in the Amiga basically loaded some stuff from disk, loaded the boot block actually, and then jumped to the code at 1564. And the code at 1564 is in what's called chip memory. It's the low down memory. Anyway, so the ROM knows that the memory is free because it's passing control to this loaded code that was loaded from the disk boot block. So this loaded code, we can have a look at the hex dump for it, which is in the disassembly view, and we can see that it has, say for example, 41FA. You can also look at it in the memory debug view as well. So let's have a look at 1564. And we can see it's 41FA001845F9, and so on and so forth. If we look at the we can also use the M command, which displays a memory debug dump as well. So this memory view, we can set the address that we want to have a look at, whereas if we want to inspect it with the M command, the memory command, then we have to type it in and then see the results here. So it's kind of useful to use the GUI debugger sometimes because it allows you to look at stuff. Oh look, there's a hidden message. So it's a hi stranger. Something about keeping the world of boot blocks. Okay. We've got TCC in there and everything. TCC is one part of that demo group or something, right? It was in the credits anyway for this demo. So we need to understand this boot block code to understand what it is doing. And we can look at the disassembly for that. We can also step through to see what it's doing. But I can immediately see that this code is basically doing a dbfw word with a previous move, and it's basically doing a ranged memory copy. If we have a look at 1500 in the memory, we can see actually that the system ROM, the kickstart code for the Amiga, has loaded a whole bunch of data into RAM, and I think it starts at 1558. That memory start code there, or the data that's in memory, corresponds to the start of the information in the ADF file, which is a disk image file, and basically it looks like it's just basically the raw blocks. The ADF file doesn't look like it has any header information, which is interesting to note. So the kickstart, the bootloader, whatever, has loaded this chunk of data from the disk, which comes from the disk image, into memory. The Amiga emulation doesn't know that it's a disk image as such. It just basically assumes that it's a disk drive, right? Anyway, so we now know where the data in the disk image file comes from in terms of the bootloader code. So we can have a look at the disassembly, and we can step through the disassembly, and we can see that it's eventually getting to a jump 7F800 in hex, which is pretty much right at the top end of what we assume to be the chip memory for an Amiga 500. I think that looks like around about the right memory address. And that's at 1578, that jump there. What the bootloader code seems to be doing immediately is that it copies itself to the end of chip memory. I'm pretty sure that that memory address is at the end of chip memory, basically, minus a few bytes. And then it jumps to it. So it jumps to itself that has been copied way up above. If we scroll down in the hex editor, we can see in the disk image file we get that message. Hi stranger, you enter the deep world of boot blocks. Don't rip anything out of this demo. Ho, ho, ho. I expect lots of the demo code was ripped from other sources anyway. We've got some what looks like German in the data following it. So that's the end of the boot block loader, but then we have all of this extra data. So this looks like German. Hold on a second. My German's not so good these days, but it's was suchst du hier eigentlich, Egel, du hast es gefunden. Wenn du ein Spanner bist, dann drück im Vectorballs Part den Joystick button. Loosely translated, it's like, what are you looking for here? No matter. You found it if you're a spanner, voyeur, something. Then press the joystick button in the vector balls part. So the hidden message seems to indicate that if you're a voyeur, I'm not too sure that that's quite the right translation, but it's close enough, I suppose. But basically, yeah, you press the joystick button in the vector balls part, and something's going to happen that you can look at. If we scroll down, there's more German. Stop bis hier und keinen Schritt weiter. It means up to here and not step further, or something like that, I think. That's the loose translation. And if we scroll down a bit further, we've got some changes in data. Immer noch am Suchen. Are you still looking? Or still looking? And there's an English part. Okay, there is a trainer modus in the end part, but nobody knows. But Delta and Dr. Beat know it. And then we have a change in data at 2C00 in the file offset there. And I have a feeling that that's going to be the code that this demo bootloader will continue loading and then execute for the actual main part of the beginning of the demo. Apologies for my terrible German pronunciation, but it's about 25 years since I've spoken German in any way, shape or form. So, actually it's probably like 30 years since I've spoken German. Gosh, now I feel odd. Anyway, so let's step through one instruction using the Z command, or we can step through more instructions with the T command. Now, step through jumps over JSRs and stuff like that. T steps into JSRs and things, so we want to step into usually, but we don't want to step into kernel code. So it looks like this code here now does, if we go by what we see on the screen, it just basically does some display initialization, copper list initialization, and then this looks like it's loading information using the standard, Amiga ROM routine for loading sector data. Looks like it's telling it to load at 20000 in memory, and the cat agrees. Yeah, the cat still agrees, and it's loading 2C00 as the start address for the disk offset, rather, for the sector offset. and it's loading 58000 bytes in hex of memory. So if we have a look at what's at 20,000 in hex, initially it's all blank, and then we go, and then we can see in the emulator view, we can see that the disk sector, and the cat agrees, we can see that the disk sector counter is going up. That indicates disk activity, and then after the routine finishes in the ROM, then we return back to the breakpoint. And now if we have a look at what's in the memory, we can see that it's been populated with data. And it starts with 610001DE. And that corresponds to this data here, 610001DE. So now we can see that this disk bootloader has initialized the display, has read in a whole bunch of blocks from the disk, and then it's going to probably perform some initialization and then jump to the start of that routine which was just loaded. So now we know where the game, well, not game, we know where the demo loads code and data from after the bootloader, and we know where it loads it to. So we know that it's 20,000 in hex. So given that information, we can now change the Menace source code using Devpac. Well, we can change the source code. We can edit it to make it a fixed origin for the executable, so it's no longer really an executable, it's actually a fixed memory address. Right? It's not position independent code anymore, it's going to be position dependent, and it's going to load at 20,000. And then we can put that data hopefully in a copy of the disk image for the demo, and then get it to get the demo bootloader to actually load the Menace sample code. How does that sound? Let's try that and see what we get. So let's go back to the emulator. Let's go back and make the necessary source file changes to do that. Oh, look, my icons are all messed up again. Let's clean those up. Let's highlight the icons this time, and then let's do snapshot. I think that was the way of doing it, right? It's ages since I've used an Amiga. Snapshot, and then let's snapshot that. Let's also snapshot the disk. Just, there we go. Right, now hopefully the next time it opens up, these icons won't be screwed up. So let's open up what we're going to do now. We need to, we need to open the code. We need to edit the code, right? Yes, of course. Let's go to Devpac2 directory. Let's open the assembler editor window. Let's make it nice full screen so that we can actually do some more productive work. Let's open the source code with the Dave Jones sample. And the Dave Jones sample code is on the hard drive, so let's open that. Right, so what we need to do first is that we need to specify the origin for the code. And a good place to put the origin for the code is just here at the beginning of the source file. So let's go do that. This editor is a little bit different to the usual kind of editor that I would normally be using. It feels a little bit older, but it's not too bad, I suppose. So this is the origin that we discovered for the start of data that's loaded. These are just equates. There's no actual code being assembled at that particular point. But if we output to none and we just do a quick assembly, we can see that the org command works. So the assembler understands the org command, which is great. Now, we also need to remove dynamic memory allocation and make it just a fixed place in memory for the chip stuff, because if this code starts to try and allocate memory at the beginning of chip memory and then it goes over the actual code, then that's no good, right? So we'll just comment out, I think, the dynamic memory allocation. What we can do is that we can force D0 to be a specific value. So we will try and find the hash. There we go. That's where hash is. Pound symbol, but it's hash. I'm English. British by birth, so yes, hash. So membase real is going to be a label name that we create, and membase real is going into D0, and then it moves D0 into the membase equate. Now, D0 is used a little bit later on by this code here to calculate the offsets, but we're trying to change the minimum amount of code in this sample. So we make sure that the dynamic memory address for the allocated memory block that has been commented out is then stored back into this membase pointer. Okay, so we're just changing the minimal amount of code. So we just comment it out and we just force D0 to be like a fake returned value of membase real. Membase real, the label is after all of the ink bin and after all of the code and everything like that. So hopefully membase real will point to memory just after all of the assembled output has finished. So let's save that. Let's assemble it. And we will assemble it to a new file on the hard drive. So we will assemble it to temp and bin, and we'll put 20,000 in hex after it, just to remind ourselves that it's position-dependent code, not position-independent code. Okay, and then we just click assemble. And everything should be fine. And pass 1, pass 2, 0 errors found. Done. Well, okay, well, it assembled. Will it work? Oh, whoops, the emulator is still capturing the keys. I didn't mean to type that there. I needed to type it there. If we have a look at the output file in the hex editor, let's open the file that was just saved in the hex editor. Where is it? There it is. So this is the original position-independent executable code that was assembled first, and it runs from Workbench. And then this is the packed version of the executable. We can see that it's a lot smaller. Now, the bin 20,000 code looks very similar, right? But the offsets for memory addresses and stuff like that have changed because we're assembling it at a specific program, or we're assembling it at a specific origin start address, right? So the assembler knows that it is at a specific start address, so the offsets will, of course, change. Also, the bin 20,000 code, which is position-dependent code, is a little bit smaller than the position-independent code. And this is kind of expected as well. So let's get rid of that typo there in the source code. And then let's open up a new instance of WinUAE. I don't want to use the WinUAE that I'm using to edit the source code, because if it doesn't work, I want to debug it and then make the necessary changes, right? So I'm using a new instance of WinUAE. And I'm looking for the command to load a file from the host, from my Windows PC, basically, to memory inside the emulator. It can't open the file. It probably doesn't like that it has quotes. Let's get rid of the quotes and then use the load command at 20,000 in hex in the emulated Amiga's memory, right? We will look at the memory dump at 20,000 in hex, right? So we'll load that. And if we go to 20,000, flashing power, and it's resetting, and it's probably going to be, there we go, Guru Meditation. And I know why. The data at the beginning doesn't look like valid code. Oh yeah, look. If we have a look back at the hex view, yes, of course, 3F3 is the start of the Amiga executable hunk code, right? Yes, okay, so Devpac hasn't saved out a raw binary, it's saved out an executable hunk prefixed or hunk chunk, right, file. So we need to actually load the code, so we need to take off 32 bytes in decimal or 20 bytes in hex. So to be able to do that, what we can do is that we can just load at 20 bytes in hex previous or before 20,000 in hex. So it's 1FFE0. 1FFE0 plus 20 in hex is going to be 20,000. So there we go. Now we've got 43FA, which is the opcodes, which is the opcode for the start, and there we go. It works straight away. Well, that was a lot easier than expected, right? So using this information, you see I use the monitor, the debug monitor there, just to run the code straight in the Amiga's memory, just kind of like, you will load it and you will run it. So now we just need to get the demo bootloader to load that code. So let's take a copy of the mega demo disk image and we'll call it something like footest.adf, right? Let's load that up in the let's close the old mega demo ADF so I don't accidentally update it. Let's load the new footest.adf file. Let's go to 2C00, right, which is the start of the main demo part data. Let's copy all of the newly compiled position-dependent Menace demo code, and let's paste it over the top of here. So if we do an edit or data, then paste, there we go. That doesn't make the file larger, it pastes it over the top of whatever was there, right? Doesn't insert it, overwrites basically. And then let's start that new ADF file and see what we get. So the bootloader should come up after the disk image is actually plonked on top of the emulator. There we go. Right. Disk loader should start. It should load data, and we could see that it's loading data. The amount of data that the demo bootloader is loading is much larger than the assembled Menace demo source code. So we know that we can just safely load whatever there. And there we go. Look, it works straight away. Wow, fantastic. Gosh. Well, that was a lot easier than I remember it being. Using Devpac has triggered quite a lot of memories. Not all of them good. Large, long, very complicated debugging sessions. Now, using Devpac on the Amiga or in an emulated Amiga is, to be honest, in my view, not the best way of working. There are much better ways of working these days, and maybe that would be an extra video in its own right. We should be using compilation, cross-assembly tools. We should be using a nice, fast Windows PC with nice, comfortable text editing and source control and everything else like that. And we shouldn't really be trying to edit code on an Amiga in emulation anymore, because it's a bit clunky, right, and awkward. I would much prefer to use a much higher resolution display and a much nicer font and everything else like that. So I think we should be using, external cross-development tools, and then just basically squirting the files or disk images to the emulator. So maybe that's an extra video. But anyway, that's basically, up until that point, that's the video that I really wanted to do for the Amiga and my retro games view for the Amiga stuff. Is there anything else I wanted to touch on? No, probably not, I don't think. So, oh yes, I'm using the commercially available version of Devpac, because the version that was available on the cover discs is a cut down version. You can't save from it, if I remember correctly. You can't really use it that much. It's size limited in terms of the size of the source file that you can assemble. On the original cover disc 7, I remember actually, oh yes, there was Argasm. Argasm was a different assembler that was released as a demo, or as a demo of Argasm, which was released in the cover disc previous to the demo version of Devpac. Anyway, so like the README says, it's a demonstration version of Argasm. It's actually by Argonaut Software Limited. So I remember looking at this back in 89, 90, or whenever this cover disc came out. And eventually, after about 4 years, I actually started working for Argonaut Software. When I got a little bit more games development experience, I just, went and interviewed for them, and they offered me a job, and I worked for them for 10 years until they, ran out of money and went out of business and liquidated. A great 10 years of my life developing games on various different platforms, but that's not really the purpose of this video. It's just a small world, right? Argasm on the Amiga Format cover disc, and then I go and work for Argonaut later on. So I think that's about all for this video. If you enjoy these kind of retro platform, retro machine games or development videos, then please do consider liking or subscribing to this channel. And if you like the Amiga stuff, then also let me know, and maybe I'll do some more. I certainly hope so, because the Amiga was part of my games development history. So thank you very much for watching. Take care. Have a great day, evening, or night, wherever you are.